So as it says in our notes and as it says in our flow chart, the first thing we're going to do is get one side equal to 0. Then we're going to factor. So that's going to take us through the middle part of this factoring flow chart that we have. Again, if it's a polynomial, not necessarily a quadratic, we're going to be looking more kind of at the factor out a GCF with some value higher than an x2 there. And also we'll be looking at that factor by grouping a little bit more. And then again, just like our factoring before, we're going to set each factor equal to 0. And then we can check our solutions. For these, it's not all that important that we check our solutions, but as we get into next week, we're going to see that it is super important that we check our solutions. Okay, so there is our first equation. It is 4x to the fourth equals 12x squared. It says solve by factoring. Notice this is not a quadratic equation right now because it has x to the fourth in it. Quadratic equations just have x squared. However, we're going to still follow our flow chart. We're going to get one side equal to 0 like it says. So I'm going to move the 12x squared over to the left. So that would give us 4x to the fourth minus 12x squared equals 0. As we go through here now and look to factor, it says look to factor out a GCF. But we do have a GCF here. What's that GCF going to be? 4x squared. So that's what we're going to pull out. And then we're going to divide everything by 4x squared. So inside our parentheses, 4 divided by 4 is 1. X to the fourth over x squared is just x squared. And then we have negative 12 divided by 4 is 3. And the x squareds cancel out. So there's two terms in there, but they're not both perfect squares. 3 is not a perfect square, therefore we can't factor that further. Okay, so we'll be over here. But we still want to set each of our factors equal to 0 then. So one of our factors would be 4x squared. And our other factor would be x squared minus 3 equals 0. So when we solve the first one, we would divide by 4. X squared equals 0. So x equals 0. Remember, we would want to do plus or minus if we had to, but there is no such thing as plus or minus 0. It's just 0. And then for our second one, we're going to add 3. And then take the square root of 3. There's no perfect square that divides into 3, so we're just writing it as plus or minus root 3. And so we would get negative root 3 as one solution, 0 as another solution, and positive root 3 as a third. Now it did say to check, so we'll check for this one, but unless we really have to check, which we'll talk about later when you absolutely have to check, this is just double checking that our answer is right. So if I check 0, 0 is the easiest one. I'd have 4 times 0 to the fourth equals 12 times 0 squared. 0 to any power is 0. 0 times anything is 0. So we get 0 equals 0. So that checks out. So we know that one's good. And then I have the square root of 3 to the fourth. And then 12 square root of 3 to the second. So if you type the square root of 4, or sorry, the the square root of 3 to the fourth, you can think of that as the square root of 3 squared, if you want to think of it that way. It makes it a little easier to think about. Because what happens then is the square and the square root cancel, so you're left with just 3 squared, which would be 9. So that'd be 4 times 9, which is 36. And then here, the square and the square root cancel, so we're doing 2 times 3, which is 36. 36 equals 36, we're good. And then if we made this negative root 3 instead, sorry, negative square root of 3, since we are taking even exponents, we're getting the same answers. This would give us 9 still because it's an even exponent, it has to be positive. Since we're squaring this, it would still be positive. So you get 36 equals 36 again. So those are 3 answers. They're all correct. Again, if we just have these polynomial ones, I wouldn't bother checking them really unless you're really not sure. There will be a time when we come up here where we really absolutely have to check. All right, so let's try this one now. 2x to the third plus 3x squared equals 8x plus 12. All right, so again, according to our flowchart, first thing we're going to do is get one side equal to 0. I'm going to move the 8x and the 12 over to the other side. So we get 2x cubed plus 3x squared minus 8x minus 12 equals 0. Okay, now we start our factoring. We look for a GCF. Is there any GCF in that entire 4 terms? No, right? There's 4 terms in there, so we're coming over here in our flow chart, and so that tells us we're factor by grouping. So that's taking us back to factor by grouping. Remember, factor by grouping, we group 2 terms together at a time. So I'm going to group my first 2 terms together, put a plus sign, and then group my last 2 terms together. And once it's grouped, we pull out a GCF from within those groups. So in the first grouping, what's our GCF going to be? So our GCF in these 2 terms. Elliot, what do you think? All right, so I'm pulling out x squared. So I'll be dividing each of these by x squared. And that will give me 2x plus 3. As I look at my next 2 terms, what am I pulling out as a GCF? Negative 4. Make sure it's negative as well. And I'm dividing each of these by negative 4. And we would get positive 2x plus 3. Thanks. All right, now we notice that inside the parentheses there's a 2x plus 3 inside each of those, so that's what we're pulling out as a GCF then. So I'm dividing each of these by 2x plus 3 essentially. And so I'm left with x squared minus 4 equals 0. Now, if you want to factor that further, the x squared minus 4 is what kind of factoring going to be there? Perfect squares, difference of squares. You definitely can factor with difference of squares, but since this is an even exponent, we could also just leave it like this and just set it equal to 0. So it's your personal preference on what you want to do. Whether you just set that factor equal to 0, or you could factor it again as x plus 2, x minus 2. That would work. Either one of those would work. Okay, now we're going to solve. Minus 3 and divide by 2. So we get negative 3/2 as one answer. If you were setting each of these equal to 0, we get negative 2, positive 2. We'll get the same thing here because we're going to add 4 and then take the square root. And remember, when we take the square root, we would need plus minus. So plus or minus 2. Same thing as we got here. So our three answers we get for this one, negative 2, negative 3/2, and positive 2. So again, we're just bringing back the factor by grouping essentially. Nothing crazy, but bringing back the factor by grouping and ultimately setting it equal to 0 then. All right, so take a moment and try those two problems on your own or in your groups. I hear your answers for those two then. And then we're going to do one more example with one last type of factoring we haven't done in a while. You'll have some time to work. So we have 3x to the fourth equals 81x. And again, first thing we're asked to do is get one side equal to 0. So I'm going to subtract 81x from both sides. All right, from there, again, we're going to pull out a GCF. What's our GCF going to be here? 3x. So I got x cubed. 81 divided by 3 is 27. And so this is where it's a little tricky because if we go through this a little bit further, I can't just set this one equal to 0 because it's an x cubed. Okay, x squared we were able to because we were able to get plus or minus. But when it's an x cubed, we can't just set that factor equal to 0. So if we kind of go through our flow chart, there's two terms that are inside our parentheses still. And so again, our options are difference of squares. Well, that's not difference of squares. Not factorable or sum and difference of cubes. Is that sum and difference of cubes? Yeah, it is. Okay. So we now have to factor that with sum and difference of cubes. Sum and difference of cubes is on your flow chart, the formula, but it's also right here. So remember that a cubed minus b cubed. So that a is really x because we're taking the cube root. So our a is really x here, and our b is going to be 3. So the 3x is staying in front. That's the GCF. And then I'm following the difference of cubes formula. So it's a minus b, so x minus 3. And then it's x squared plus ax, so plus 3x plus b squared plus 9. Now I can't factor that any further. But when I go to solve this, I'm going to have to solve this somehow. So I would have 3x equals 0. When I divide by 3, I would get x equals 0, so that's one answer. X minus 3 equals 0, that would give me positive 3. Second answer. And if I have something, a quadratic that's not factorable, how else can I solve quadratics if they're not factorable? You just took quizzes on it. It's another way besides factoring you can solve a quadratic. Whoop. We can do the quadratic formula. So guess what we have to do here? Oh, what fun. All right, so I'm essentially setting this equal to 0. So my a is 1, my b is 3, my c is 9. So I have x is equal to negative b, so negative 3, plus or minus the square root of b squared, 3 squared, minus 4ac, so 1 times 9, all over 2a. So we want to get that radical and simplify that radical, the discriminant part. 3 squared is 9. 4 times, negative 4 times 1 is negative 4. Negative 4 times 9 is negative 36. And so we end up 9 minus 36 is negative 27. So what kind of roots are we getting from this one? Well, if it's negative, imaginary roots. Okay, so what perfect square goes into 27? So I write this as root 9, root 3, and root negative 1. So I get 3i root 3 as my radical. So negative 3 plus or minus 3i root 3, and that's all over 2. If I look to reduce that, I can't because 3 over 2 doesn't reduce. So therefore, my answers would be 0, 3, and then you can just leave it as negative 3 plus or minus 3i root 3 over 2. So whenever you're using sum of cubes or difference of cubes, most times that quadratic that comes out is going to be an imaginary root. So you're going to have to do quadratic formula. It's never going to be factorable.